Okay, so it seems there's a lot of people uh, trying Linux, and I've seen like many like misconceptions and people confused, and people trying to explain like how many things work, in particular the package manager. So I thought I will. So in this video, I'm gonna explain that. I'm gonna explain how the package manager works, but also all the different package managers and other solutions, so that you understand like there's definitely issues, but you need to look under the hood in order to understand like I make recommendations to people like don't do this, use that, but if you don't know what's happening behind the scenes, then you are just gonna ignore my recommendation. So I'm just gonna explain why I make the recommendations that I make. Um, so one of the explanations I saw from somebody who's a newcomer, which I thought it was kind of good, um, is that the package manager is like a store. So let's say like we have a we have a store. You go to the store and then you buy stuff. Sorry. You have there are some items in the store. You go to the store, you pick some items. But in Arch Linux, specifically, that's where the things become a little bit tricky. Um, you have the AUR, Arch User Repository. I mean, to me, this is very obvious. That's what's going on behind the scene, but some people might not realize. So she came with an analogy where you have like a factory. I don't know if you use like a factory. So so this will be like it will be like so it will be like Pac-Man, and this factory. Let's put it. This factory is gonna be like AUR. Okay, so you build some stuff in the AUR, and then um, you install it in the package manager, something like that. And then there's other stuff like mm, here you will have Yay, which is one of the many tools to basically interact with the AUR. So this is very simplified view of this, and if you are not using Arch Linux, why will that matter? I'm gonna show why, but um, let's consider first like let's say you are here, mm, you are here, and traditionally you will just get the packages from here, but in modern uh, distributions, like they provide like something like like a store. I'm gonna this will be like the actual store, which I'm gonna call the Discover, because that's the name that I'm gonna use, uh, the software that I'm gonna use. But this is like uh, interface, graphical user interface that is supposed to be user friendly, and then you get the stuff from there, and then there's some stuff happening here that's messes up everything. Um, yeah. So first, let's explain like all the different uh, packaging systems, which are like Pacman, Debian, and RPM. Those are the three main. There are others, but there are so few distributions use them that it's not worth even mentioning them. So let's look at this from the point of view of a developer, because I mean you don't need to know how they are constructed, but if you do, a lot of things make a lot more sense. So let's do that. Before we even look into the packaging stuff, let's look at what is called the upstream. Upstream is like, well, I'm thinking like, oh, let's say Chromium. Chromium is developed by Google, basically. There's uh, an open source community, but there's some like distribution free development. And it has nothing to do with Ubuntu or Fedora or anything. So that is upstream. That is the thing that all distributions use. I created a very simple program in C that is basically just going to print some string and the version of a library. CLib is a compression library that is used by pretty much everything. And then the make file is like really simple. It's just instructions how to build. So I just do make. So it builds. And then I run it. And that's it. So this is the version of CLib that I have on my system. I can verify like by asking Pacman, which is the package manager of Arch Linux. I'm using Arch Linux, by the way, and it says version 1.3.2. Okay, so far so good. But actually, I'm going to show like before even trying to do the packaging stuff. There's a way to install this that is independent of any distribution. So what I do is like create a directory here, change so prefix is gonna be opt hello install. Okay, so basically in this prefix I install this quote unquote package, and then I just run it and it just works. Of course, this is just one file. A package is going to contain like a lot of binaries and libraries and header files, documentation and so on, translation stuff and so on, but everything is going to be in this directory. That's how some uh, like alternative distributions do it. If you compile stuff from scratch, you can, that's how you can do it. But let's ignore that and then look at how like an actual distribution does this. So the first thing is so they create what is called a tarball. A tarball, you can consider it as a zip file. And a tarball, I think, is with L. Right. So this just contains these files. That's it. So this tarball is released, and that's what all the distributions are going to use. So Arch Linux and Arch Linux based distribution like Catchy OS, which is pretty popular right now, use this method. Basically, you just need one file, this pkg build. It is very simple. There's some security stuff. They specify the file dependencies. The architecture is gonna be like x86, and basically that's it. Make install exactly like I did. So let's build this package. That's it. This is the package that was created. There's some debugging stuff that is only needed if you're gonna, well, debug, if you are a developer or you wanna debug try some bug or something. So let's install that package. Yes, and now we have a package called hello. This is all the information of that package, like the metadata. You can list the files. You can I can run it, and that's it. It's exactly the same thing, but now it is packaged. Now there is nothing complicated about this. Like basically all the package managers have like a bunch of files contained in a package and some metadata about that package. There's nothing complicated about that. But where it becomes tricky are the dependencies, and that's where the thing that is not present in Windows becomes important. Because in Linux, you have this shared libraries, and these are like the most complex shared library system that I have seen, where we have a binary, and that binary has some libraries that are linked dynamically. So when you run this file, this binary, it's gonna load all these dependencies at runtime or launch time, and that's how like this program like this function is not present in this program, is present in this libc library. So all of this happens automatically. Linux knows exactly what to load, how to put in memory, and multiple programs can use the same library, and Linux is smart enough to know that, okay, this library is already loaded, we're gonna share this memory among all the programs. It's extremely complex. You don't need to know all that. All you need to know is that because of this dependency, that's why this package depends on this other package. And one package depends on another package, and that second package can depend on other packages, and so on. So and this is unique in Linux. I mean, okay, maybe FreeBSD and OpenBSD or some of those or something like that. But in Windows, that's not the case. Windows shared libraries are very simple. They don't track dependencies, and that's why when you install a program, that program has all the libraries that it needs. They don't share libraries. So that's the difference with Linux. In Linux, there are shared libraries, and all the package managers deal with that. That's why it's very easy to have package managers in Linux, not so easy to have package managers in Windows. So let's look at one real package like OBS. Uh, if I do this, I don't know what LDD stands for, like linked. Uh, I don't know, something about linked libraries. These are all the libraries, shared libraries that OBS needs. As you can see, there are quite a lot. But this is actually not the whole picture, because if I do um, this command, actually there's not that many shared libraries, but each one of these has in turn other dependencies. So if I do like this another shared library needs other shared libraries. So basically it's like a tree of shared libraries, and all those combined is the result, is this result. And this reality of shared library dependencies, that's what the package manager tracks. If I check OBS Studio, it says it depends on these other packages. But FFmpeg is one package, and that package depends on other packages, and so on. So there's a reality of Linux and shared libraries, and the package manager is tracking that, so that when you do, like, when you install one package, the package manager is going to figure out all the dependencies of the dependencies, and which ones of those you already have and which ones do you need to download and install. So that's the complexity of the package manager. Um, Pacman is in itself like rather simple, and as you can see, like, the package build is um, very simple, and this is what is in the AUR. AUR is just basically these files. So when you do like Pacman S and then like OBS Studio, this is gonna download this a file like this, a pkg tar cst, which basically just contains files and metadata. But those files are binary. If you use the AUR, then you have to build this file based on this. The pkg is gonna download the source file, and then it's gonna build it with a compiler. So you need compiler installed, a bunch of development stuff installed, basically. And that is different in other distributions. In other distributions, this factory stuff is not really present, right? So you're kind of screwed, but they have other solutions with all when other people compile that stuff, and even if though it's not official, you can still like download the binary package and install it. But anyway, the Arch Linux solution is that the AUR contains all of these source stuff. Actually, let's look for something. This one, like mesa git. It's just one file that contains the instructions how to build something. But it's source file. This is source code. It's using Git. You are gonna have to download this and install. Actually, there's another one. This one might be more appropriate. Actually, these are binary, so it's not exactly the same. But anyway, it's just instructions. Instructions how to build a package, and you have to build the package. That's what the AUR stands for. There's no like direct counterpart in other systems, but it still matters how they are built. Okay, now let's look at Debian. For example, Ubuntu is a Debian-based distribution. So Ubuntu and all the distributions that are derived from Debian use this system. So in Debian, instead of having one file, okay, let's type F. You have a bunch of files. This rules file, which is basically like what instructions to do in different steps. This control stuff, which basically states like the metadata, dependencies. These are basically like telling like figure it out automatically. Actually, this shouldn't be here, I think. I mean, it's redundant, but okay, we'll see. Change log, like release notes and some other stuff, right? So it's more complex, and this is like a very simplified package, because usually because you have to do so many things, people add even more things, so it deviates from the original upstream package quite a lot. But okay, so because I'm running Arch Linux, I have to do more stuff in order to compile this. Okay, let's so let's run this. Okay, so this is like a container thing, kind of, where I'm running a Debian system. Can I? Anyway, so this is not my system. Let's copy, but for example, it doesn't have Pacman, but it has DPKG, which is the Debian packaging system. Let's copy the tarball, which is like the upstream source code stuff, for extract it, and then copy the Debian directory on all the files in that directory. So now, if I go to this directory, it contains like these are all the stuff that Debian needs to build the package. Okay, in our container. So let's build the package, and that's it. The package, Debian does a lot more stuff, but the package at the end of the day is this one, .dev. So I can just do dpkg install .dev, and then let's list the files of our package. Sorry. It is similar, but like Debian requires like more information, like the change log, what's changed. I think that's not really very useful, but whatever. If I run this binary, you can see that actually this version is different. So in my system is 1.3.2, in this containers is 1.3.1, because Debian is this container has a different package, but at the end of the day, it is the same thing. It is using this shared library stuff, and this libc is like it is packaged by this package. So Debian is doing basically the same thing as Arch Linux. You have packages, and then you have metadata about the packages and the dependencies. Slight difference is that I did not have to specify the dependency. This edge leaf depth steps finds out the dependency automatically. Actually, yes, here it says like that is one dependency, that is the other dependency that I didn't actually specify in the package, in the description of the package. But at the end of the day, all of these things rely on the same thing, this shared library, the dependencies. This is going to be different for other languages, for example, Python. In Python, you will have to specify the dependency manually, but anyway, at the end of the day, is keeping track of all that stuff. So that's pretty similar. Why aren't they like? Why isn't Ubuntu using Arch Linux Pacman then? Well, there's a lot of historical stuff. Like for starters, Debian was created when there was no internet. So that's why you are gonna use a tool like apt. If I do like apt info hello, that's actually gonna use internet stuff, and then this is another package. This is not my package that I installed. So basically you have a tool on top of a tool, like apt is built in top of Pacman, dpkg. When in the case of Pacman is one tool for everything. One tool for querying like local packages. Same tool to query for remote packages. Like what will be like Steam. Like this is like not my local package, but this is the remote package. Anyway, so it's different, and they track different information. For example, sorry, not this one, like OBS Studio. These dependencies are the same as Debian, but this, and sorry, not this one. Okay, sorry, this was wrong. Fmpeg. But in Arch Linux, there's like the reverse dependency. Like what packages require this package? Well, this one, like OBS Studio, Shotcut, which is an editor, and so on. This is a media player. Debian doesn't have that. So you can find that information, but it's not straightforward. So they're not the same. They're like superficially they do the same thing, except it's not pacman, it's apt, like apt install, like I don't know what could I install here, like maybe Vim. No. Yes. As you can see, installing these dependencies, because obviously I don't have these packages. Continue. No. But that's not. But that's apt. That's not dpkg. So there's two tools. In fact, there's other tools that do kind of other stuff. In Arch Linux is basically one tool for everything. Like if you ask me, like Ubuntu and all the distributions should just use pacman, and whatever features are not present in pacman, just add those features. But yeah, that's why there's fragmentation in Linux, because people don't agree. The pacman developers might not accept some of those features, and the Debian developers, of course, are not going to throw all the infrastructure that they already have. But anyway, so that's Debian. Now, let's look at RPM. So RPM is the Red Hat Package Manager. So for example, Fedora is based on well, yes, RPM. I think Basite is based on Fedora, so Basite is gonna have RPM as well. So just like in pacman, it's just one file. It contains more information, in my opinion, like unnecessary, relevant information, like which files are going to be installed, the changelog, and so on. But at least it's simpler than in Debian. Okay, so let's look at the instructions. Okay, right. So the first thing is to build the source package. I don't know why they want to create like another file that contains basically the tarball and the spec, but whatever. Actually, this should be in sudo. And then I'm gonna use this tool. It's not as straightforward, but okay, there it is. So the result of this build process is right here. Let's look at the contents of this package. RPM package is basically the same thing. It contains some stuff, like this is like for debugging. There's a separate file package for debugging, which is similar to Arch Linux. And here's the binary. However, actually, let's see. Yeah, here's the metadata. However, like, where is the dependency here? How does RPM, well, it's not RPM, it's going to be something else, but how do they know which dependencies to install? Well, there's another information here which lists like the link library stuff, and here is libc.so.1, which is basically the shared library that this package is gonna need in order to run. So it's different. Instead of link to a package, you link to a library. That is the dependency. And that's slightly better because in theory you could have two packages that provide the same um, shared library, and you can choose which one do you want. Practice that basically never happens, but basically it's slightly different. So the three different systems use different ways to track dependencies, which at the end of the day depend on the shared libraries. And RPM is similar to Debian in terms that you are not going to use RPM directly. If you want to install something, you're going to use DNF install. I don't know what it is nowadays because it used to be yum install. But yeah, it's a separate tool in order to actually download packages from the internet and install the packages from the internet. And they may use another tool later on. So that's the result of historical baggage, which is why I prefer Pacman, because Pacman is just Pacman for everything. Right? Pacman to install a local package, Pacman to fetch query information about local packages, Pacman to download packages, remove packages, everything. Everything is just Pacman. Yeah, and for example, I can say like list all the packages that how can I say this? These are called orphan packages, which are like packages that I did not install directly, but they have no dependencies. So basically, I can remove them. That's like nobody's using this anymore. Nobody's using this anymore. That's not as easy to do in other distributions because they don't. Let's see. For example, CSTD. It says install as a dependency of another package. So I did not install this, right? I still want it because it's required by something that I use. So it should not be removed, but I did not install this. And that's the same thing for clive, I think. Yeah, I did not install clive, but clearly it's needed in my system. So, but lib comes. It was installed as a dependency of another package, but it is required by nothing. So in theory, I could just remove it. Maybe something is gonna break, but I don't think so. Anyway, so yeah, different packaging systems have different features. But in general, I think it doesn't really matter for you. You can use Pacman, you can use like Debian stuff, RPM stuff, whatever your favorite distribution uses, it's relatively fine. I still suggest that you use a distribution that uses Pacman, but it's up to you. Um, but these are like, so this is like actual package manager. Okay. Uh, let's create a new. This actual package manager. Pacman, dev, or apt, and RPM, or DNF, whatever you want to call it. So that's going to be the actual package manager. And for me, like this is good. Uh, any one of those is going to be okay. They have advantages and disadvantages, but in general, they do stuff like how Linux is supposed to be used. Okay, and I wish like the video ended here, but we are just getting started, unfortunately. So I don't know who or why, but some people in their wisdom decided like this packaging stuff depends on the distribution, even though it works perfectly fine. Why don't we create some packaging stuff that does not depend on the distribution? I don't even know what to call that stuff. I'm going to call it sandbox uh, packages. For example, Flatpak, Snap, and app image. I don't know if there's more. I don't use this stuff. Okay, so if you use a distribution like um, Fedora, let's say, you are just gonna have access to RPM packages. If you use Arch Linux, you are gonna have access only to Pacman packages. But in both distributions, you are gonna have access to all the Flatpak packages. So superficially, that sounds better because it's the same repository for all distributions. Now there are some advantages. Like I don't like this idea, but there are some advantages. But yeah, like the problem is gonna uh, pop up immediately once we look under the hood. But anyway, there's a second problem here, which is like when you use a store, quote unquote store. I don't have space here. Um, whatever. Uh, you are not gonna know like, well, it depends on the store how they implement it, but you're not gonna know. It's just a graphical interface to install stuff. And how is it being installed? Is it an actual package manager or is it a sandbox solution or something? Like you don't know. And specifically, like if you are new to Linux, you may think it doesn't matter. Like if it's Pacman or Flatpak or whatever, I just want to install stuff, so it doesn't really matter. But at the end of the day, it does. So uh, let's create a Flatpak package. Mm, Yes, okay. So once again, it's one file which contains some metadata basically, and the build commands are pretty similar. I mean, they look really different to me, but anyway, it's just one file with the information how to build a package. So let's build this package. I mean, I don't consider this a package, but quote unquote package. Okay, so we have built it. Now let's install it and run it. Well, it's an app. That's, I guess that's the better term. And that's it. I run the app and it works. But the version is different, right? Because it's once again like it's a sandbox. It's a different system. So actually, I can do is it command? Yes. So I can do this command, and now I'm inside of that sandbox, and I can find. I think it's app bin. I can find my binary. I can run it directly, right? And I can check the libraries, and these libraries are entirely different. Like this file doesn't exist on my system, right? There's no such file, right? This is a sandbox. Basically, it's a complete system inside my system. This creates problems because, like, just to run this application, all the shared libraries have to be duplicated because now they are not shared. Like, there's a way in which you can find out like how many programs are sharing this library. But anyway, basically, no programs are gonna share this library because it's another system running on top of my system. But whatever, like people have a lot of memory nowadays, right? Memory is free, storage space is free, right? Um, okay, so there's no problem, right? Like just use Flatpak and everything is gonna work fine. Um, I don't know where to begin. Like how many problems can you encounter with that? But anyway, let's just do uh, that's 2.3 gigabytes. just to run. Okay, maybe uh, mount or is it X? Okay. Um, all right, that's not too bad. Mm, I think this is not. No, this is not correct. Because it's not listing a lot of stuff. Like that's 1.7 gigabytes right here. 1.9. Anyway, uh, so this is an entirely different system than from my system, and obviously, I mean, I can foresee so many problems. But okay, maybe there are no problems, and maybe it will work fine. Okay. Mm. The first problem that I foresee is Steam. If you install Steam through Flatpak, I mean, Steam itself is like another system. It's not one thing. When you run a game, you're not only going to run it through different layers, like for example Proton. even native games, Proton itself is run in another layer, but even native games are run in another layer, which is called like a runtime. So if I go to this runtime, different games are gonna use different runtimes. But let's go to here. Uh, let's mount my disk. Okay. Actually, I don't know where. Well, just there's a there's a bunch of files, and all of these files are like they are like another entire system on top of my system in order to run games, because something a game is not gonna want to depend on libraries on a system that is constantly changing, right? Arch Linux may use like newer versions of some shared libraries that are not necessarily going to work for, let's say, an old game. So what Valve did is like, let's create a baseline like all games can rely on, uh, and that's going to be shared on all systems, whether you're running Fedora, Ubuntu, or Arch Linux. You're going to be running games on the same runtime, right? So it's actually a good solution for games, right? So I have this script here where I'm gonna run my upstream binary, and I run it on the Steam runtime. And all the Steam runtime, there's at least 3 on my system, so I don't know which games use which. It just works. So the version of CLIF is kind of is old, right? If I do, can I do LDD? No. Mm, okay, I know. Let's do this, run, LDD, upstream hello. I think like that. All right. It's using clearly libraries that are on another, like somewhere else, right? So every single time that you click play on a game, there's a bunch of stuff that Steam is doing that is like basically launching another system on top of your system in order to make sure that the games work reliably on all distributions. Okay. Now, if you install Steam on Flatpak, you're gonna have what like let me my mind is like how do I explain this? Um, so you are gonna have the system like native system like libc 1.3.2, like my native thing, and then you're gonna have Steam, which is gonna have like a Steam runtime, like Sniper. I think that's what they call the code name of the 3.0. And on top, no, wait, no, that's not how it's gonna work. It's gonna be here. No, you're gonna have Flatpak in the middle. Flatpak, when it's gonna have another libc, whatever, 1.3.1, right? So you're gonna have like 3 runtimes basically. And this one in the middle is designed specifically as a sandbox, so it's not gonna allow this Steam runtime to have direct access to whatever is on the system. And Steam is doing really smart stuff to like bypass, like, okay, like this stuff, yes, I want to go through this native system, and this stuff I don't. But if you go to Flatpak is not gonna be nearly smart enough. So, and okay, that's if you use app image, it's gonna be different. If you use Snap, it's gonna be different. So, yeah, like there's not gonna be any problems there, right? So that's the first problem that I see. Like, do not install Steam on Flatpak or any other thing like that. Just install it directly, and it's not that hard. Sudo pacman steam. That's it. No problem. Right? Why go through? This is just asking for trouble. But okay, like other than Steam, right? Maybe there are some other like simple applications. All right, let's see. Like uh, these, well, let's go to the I don't know how many problems. The third, the meta problem. Okay, so the meta problem is that even if you want to use Flatpak, okay, it's fine, but newcomers are not gonna know what Flatpak is, what Pacman is. They just see a store, click on the store, and install stuff, right? So that's really what concerns me the most. Like, I'm not a prescriptivist. You want to use Flatpak, use Flatpak, fine, whatever. But newcomers are just gonna use the store, and there is no store. I made a video about how LTT, like they're supposed to be like technical people, and even they are like, I don't care. I just click install. Like all right. I don't know all of the different quote unquote stores. I know some solutions that are like graphical user interfaces for Flatpak and similar stuff. I know there's a thing called a package kit, which was supposed to uh, be like an interface so that you can use the same commands, and it will use Pacman in one system. It will use apt in another system and so on, but it doesn't seem like it worked, and I don't know, like I don't know. So I don't know which distributions use which solutions, and I don't really care because I just use Pacman and Pacman just works. So whatever this store is, like nowadays, my real worry is that it's gonna just use Flatpak by 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 default. That is not gonna tell users like, okay, do you want to use Flatpak or do you want to use native packages? And it's actually something worse, which is unfortunately it seems like that's what is happening. So, but okay. let's put a question mark here. So this store, I don't know what it does, right? It could do a bunch of um, things. Um, it could do native. I'm gonna call it PM, package manager. It could use, actually it's pretty much native or sandbox. Sandbox apps, because these are not actually packages. Okay. All right. So yeah, that the problem is that I don't know. So what I did is so again my better judgment, I installed a quote unquote store, like I Google what kind of store will CatchOS use. Like I don't know. This is KDE Discover. There's like GNOME software something. So this seems to be like a good example of what the newcomers are gonna face. And okay, it's nice. It's a user interface. You have like nice stuff, VLC. I will not run wide this Steam, like no way, but whatever. So it's like let's install something small. I don't want to test the boundaries. So Meld is a tool that I have used. Small, okay. So a user is just gonna click install, right? Installing, downloading. I don't know why it's taking like this long, but okay. Um, I just realized these errors. I mentioned package kit. There is no package kit backend. So maybe if I install the package kit backend, that will be better. But and that's the problem. Like an expert, and FW. Okay, so this is like for firmware, I think, which I've never actually done. Still downloading. Like I could like pause the video and resuming when it ends, but like no, this is like that is the whole point. Like this is what new users are gonna face. Okay. Uh, Launch. Okay, I've never used Meld like this, but okay. Let's compare two files. It doesn't work. That's the new and modern, like quote unquote store cannot even access my file system. Right? Because it's in a sandbox. I mean, I with my expertise understand why it's not working, but how is a new uh, A newcomer gonna know that. So no, it doesn't work. And the way I actually use meld is, for example, here. Like I want to call this uh, binary with some options. It doesn't work because, of course, it's not. There's no command called meld, right? Because it's installed in a sandbox. Yeah, that's very nice. So much time like for that. How is Steam gonna even work in this shit? And I wasn't even asked. Do you want to install it with Flatpak or do you want to install it with the package manager? They didn't even ask me. So for me, this is complete and utter shit. But anyway, let's install meld like usual. No dependencies needed. Install meld. There it is. That's it. Meld is installed. It was 5 megabytes. Takes no time to download and install. I run meld and it works. And I can actually it works. And more importantly, I can run it from the command line and actually like use it with Git. It just works. Like why on earth will anyone install meld with that other thing? And I mean that's honestly it's like it's even worse. It will be better to not have any user interface so new users cannot shoot themselves in the foot. And this is not all because this is all the stuff that I had to download just to run this modern store. That's half a gigabyte just to run that shitty store, which doesn't even allow me to install packages, native packages, right? So it's just for sandbox apps. Why? Because that's easier. That works on all distributions. Yeah, but it. So when I say don't use the store, just do sudo pacman s. That's not just me being a dinosaur. That not me like not like adjusting to the new things. It's just that's gonna be guaranteed to work. Period. If you use I don't know Ubuntu, just apt install. Same thing. It's just if you use like if you want to use Flatpak, use Flatpak but directly, like not through the quote unquote store because that's not gonna let you choose like do you want to install natively or do you want to use the sandbox. They just use whatever is easier for them. So that's why I recommend just use the actual package manager. That's it. But it's not just that. Okay. Let's remove this useless stuff. XFCE panel clock. So this is my package actually. I created this package. Um, this package creates a plugin. This plugin is used by the XFCE panel. The XFCE panel is a binary. Right? This binary has a bunch of dependencies. My plugin has a bunch of dependencies, which are basically the same. But these two things interact with each other because they share stuff. They are like the binary is gonna load this plugin, and this plugin is gonna like I can add it here. It's this one. How can I install a plugin on Flatpak? You can't because everything because it's a sandbox and everything in the sandbox ha, everything that you're gonna use has to be on the sandbox. So you have to install the XFCE panel with all the plugins that it's gonna use. You cannot have plugins basically. And how many um, applications use plugins? Like I don't know, like GIMP, OBS maybe has some. I don't actually know. Blender, doesn't Blender has some? You install Blender with Flatpak. How are you going to install plugins? Like, I don't even know. Like, but hopefully it's clear now. Like why? Uh, well, it's just tricky to use a store. And again, you wanna use Flatpak, but you have to know what you're doing. Just don't open a store and click in install and hope that it's just gonna work. Like nothing is magic. There's a lot like this, like decades and decades of work in order to make shared libraries work reliably and efficiently, and all the package managers to map to that reality directly, and then you use a new technology that is not tested, it's not necessary, it doesn't work well with other similar technologies um, like Steam runtime. Well, yeah, good luck. Like my recommendations, my recommendation to newcomers is install packages manually through the command line with the actual package manager. Whatever package manager your distribution uses, use that. Hmm. Yep, I think that's it. Oops. Like it's extremely easy, efficient. It just works. Um, yeah, there's a lot more stuff. I think I'm gonna create a video because all just the way that Steam does things is like quite interesting, and there's a lot of details uh, on how shared libraries actually work. I just like scratched the surface, but well, if you just want to ignore all that and just use Flatpak, well, through a store, good luck to you. Cheers.